Welcome to Synapse Daily. Today, we analyze an architectural ghost that still haunts every modern urban planner. We are traveling back to a pivotal moment in history. The year is 1963. Japan is standing at a massive crossroads. The post-war economic miracle is in full swing. Industrial production is skyrocketing. The skyline is filled with cranes. But Tokyo is dying of its own success. The city has become a radial nightmare. It is a structure designed for a feudal era, now trying to breathe in the age of the machine. All roads lead to a single, hyper-congested center. That center is paralyzed by unyielding traffic and toxic pollution. There is a total lack of physical space. To the west, the mountains block expansion. To the east, the Pacific Ocean waits. Tokyo is a physical cage. Kenzo Tange, the titan of Japanese architecture, looked at this cage and decided to break the bars. His tool was the Tokyo Bay Plan. This was not just a design. It was a manifesto for the future of humanity. Chapter 1: The Death of the Radial City. To understand Tange's genius, you must understand why modern cities fail. Most ancient cities are circular. They grow organically like the rings of an old tree. But in the age of the high-speed automobile and the Shinkansen, a circle is a lethal trap. In a radial city, everything converges on one single point. This creates a centripetal crush that destroys efficiency. As the city grows, the center becomes more pressurized until it breaks. Tange argued that Tokyo needed a linear system to survive. He proposed a radical civil axis. This wasn't just a simple road or a long bridge. It was a massive, 18-kilometer-long urban spine. This spine was designed to stretch directly across the water from Tokyo to Kisarazu. By moving the city's heart onto the water, Tange wanted to achieve something impossible. He wanted to free the land for parks, greenery, and human culture. He believed the land should be for people to breathe. Meanwhile, the ocean would handle the heavy lifting of commerce, logistics, and transit. He saw the bay as a blank canvas. He saw the water as the only place where a truly modern infrastructure could be built from scratch. He wanted to replace the closed system of old Tokyo with an open system that could grow infinitely. Chapter 2: The Engineering of the Spine. The spine was a masterpiece of structural engineering theory. It was far more complex than a standard highway. It consisted of a series of interlocking, three-dimensional space frames. These were the giant vertebrae of the city. Each unit was roughly 1 kilometer long and several hundred meters wide. These massive units were supported by giant concrete pillars. These pillars were anchored deep into the seabed of the bay. Tange didn't just want to pile dirt into the water. That is land reclamation, and he hated it. He thought filling the bay with soil was primitive and destructive. Instead, he built a megastructure. The spine was designed with multiple vertical levels to separate different functions. The lowest levels, these were dedicated to heavy logistics, waste management, and automated freight. The middle levels, these were the high-speed arteries for the Shinkansen and local monorails. The top levels, these were massive high-speed motorways for private vehicles. This vertical separation was revolutionary for 1963. It meant that a person walking on a residential deck high above would never see a delivery truck. They would never hear the roar of heavy freight. Tange was describing the smart city logistics we are still trying to figure out in 2026. He envisioned a city where transit didn't interfere with living. He treated the flow of people like the flow of information in a computer. It was a cybernetic approach to urban planning. Chapter 3: The Metabolism Philosophy. Why is this movement called metabolism? This is the most fascinating part of the story. In biology, metabolism is the process by which a living body maintains life. It grows by replacing old, dead cells with new, healthy ones. Tange and his group of young architects applied this biological law to steel and concrete. He realized a fundamental truth: different parts of a city age at different speeds. He observed that a bridge's structural lifespan is 100 years. However, a kitchen's lifespan is 15 years. A family's needs change every 5 years. In the Tokyo Bay plan, the massive concrete frames were the permanent parts of the city. These were the bones. The houses, the capsules, were the temporary parts. These were the cells. He designed residential A-frames that looked like giant triangular hills rising out of the waves. Inside these concrete skeletons, people would plug in their prefabricated living modules. These modules were built in factories and delivered by ships. When a module got old, or when a family grew larger, a giant crane built into the structure would simply swap it out. You wouldn't renovate your house, you would replace your cell. The city was designed to never be finished. It was a permanent construction site. It was a city that was constantly renewing itself, just like a human body. It was architecture that accepted the passage of time instead of fighting it. Chapter 4: The Tsunami and Earthquake Question. The biggest criticism of this plan was always safety. Japan is the most seismically active country on Earth. The Tokyo Bay is a zone of high risk. How do you build a massive, 18-kilometer bridge city over a major fault line? Critics at the time called Tange's plan a suicide mission. But Tange was prepared. He worked with the best structural engineers of the 1960s. They designed cycle control joints for the spine. These joints allowed the massive structure to flex and bend during an earthquake. They acted like giant shock absorbers. Tange actually argued that building on water could be safer than building on land. In a major earthquake, traditional ground-based buildings suffer from soil liquefaction. The ground literally turns into liquid, and the buildings sink. A floating or pillar-supported structure in deep water can avoid this. The water itself acts as a natural dampener for the seismic waves. However, the plan faced a different kind of enemy, the ocean itself. The cost of the specialized steel required to resist saltwater corrosion was astronomical. To prevent the city from rusting away, they needed high-tensile, anti-corrosive alloys. The technology to mass-produce these materials at such a scale simply did not exist in 1963. This was the project's true death blow. It wasn't the earthquakes that killed the dream, it was the chemistry of salt and steel. Chapter 5: Why It Matters Now. The plan was eventually rejected. It would have cost more than the entire Japanese national budget at the height of their boom. The government chose the safer and cheaper path of building on reclaimed land. But Tange's ghost never left us. Look at the line in Neom today. Look at the modular skyscrapers in London. Look at the floating cities being proposed by the UN Habitat to fight rising sea levels. They are all using Kenzo Tange's notes. He was the first architect to realize that if humanity wants to survive, we have to change our relationship with the earth. We have to stop treating land as our only option. He saw the ocean not as a barrier, but as a gateway. He saw the city as a living system rather than a pile of bricks. Tange's 1963 plan is a powerful reminder. The greatest cities are not built of stone, glass, or steel. They are built of ideas. They are built of the courage to imagine the impossible. Even a city that was never built can change the way we live today. It remains a blueprint for a future we are still trying to reach. Like this video if you learned something new. Comment your thoughts below and subscribe for more fascinating stories.